Diamonds are a highly coveted gemstone and are found in various places around the world, including Africa, Asia, North and South America. We've already made a video here that shows 7 places that are open to the public where you can find diamonds and other gemstones such as rubies, opals, and sapphires, as well as other videos where I show you firsthand what indicates the presence of diamonds in a particular region. For example, garnets, diopside, mica, white quartz, kimberlite fragments, and other minerals that signal the presence of diamonds. And in case you didn't know, one of the most accessible and overlooked places to search for these indicators is directly on the ground, especially in and around dry and flowing rivers, or even on your own property. And here's why. If you take a diamond and a river rock of the same size, you'll notice the diamond is going to be much heavier. So even though the current can carry diamonds for miles downstream, it's only a matter of time before that diamond settles, sinking between the river rocks and getting trapped in the gravel. And that's exactly how rare, fortune-worthy diamonds can end up right on the ground, especially in alluvial deposits, which are gravel-rich zones that form naturally in riverbeds and bends over time. But even with all this information, many people still have doubts about how to actually find and identify real diamonds in nature. And it makes sense. Diamonds are rare gems, formed under extreme pressure and temperature, and not easy to come across. But here's the surprising part. Many regions where diamonds can be found have never been explored at all. So in today's video, I'm going to answer all your questions and give you the knowledge you need to tell whether diamonds might be hidden in rivers, mixed in with the gravel beds around you. So stick with me for just a few more seconds, because what you're about to learn might change the way you see the ground beneath your feet. To get started, you first need to identify the right diamond indicators, which I'll explain in more detail shortly. But to start prospecting, all you need are sieves. This is hands down the easiest and cheapest way to begin searching for diamonds. If you can get 3 to 6 different size sieves, you're ready to go. And the most accessible place to begin is in river alluvium. That's where you'll need to identify the minerals present in these alluvial deposits. Just take a look at how full they are of stones, gravel, sand, and silt. This is where diamonds can get trapped, often buried deep beneath all that material due to their high density. So if you use the sifters I mentioned in a river like this, you might uncover a diamond, or even other rare stones like rubies and sapphires. And like I've explained in other videos, these alluvial deposits were often formed millions of years ago. That's why diamonds and other valuable minerals like gold and titanium can still be buried there today. Now let me ask you something. Have you ever seen this type of gravel in a river near where you live? If the answer is yes, then pay close attention, because there's a real possibility you could find diamonds on the ground right in your area. But don't get me wrong, the purpose of this channel is to inspire you to develop this incredible and therapeutic hobby that gets you outdoors and in touch with nature. As I've said before, diamonds are hard to find, but this kind of knowledge could change your financial life forever if you discover just one quality diamond in the wild. And remember, while the best diamonds are still found in underground mines, many valuable ones are hidden in plain sight, right on the ground. And now you may be asking yourself, but how am I supposed to find a diamond in a river? Well, let me show you. Look at this rock here. This is the famous kimberlite rock. If you find one of these rocks in your area, there's a good chance you'll find diamonds nearby. These kimberlite rocks are nothing more than lava that comes from the Earth's mantle through volcanic eruptions. In this process, the diamonds that are formed in this region end up being brought along with this lava, which when it cools ends up trapping the diamonds inside. However, over the course of thousands of years, the forces of nature end up fragmenting some of the kimberlitic rocks, releasing the diamonds trapped inside. The diamonds are carried by the wind, torrential rains and downpours to the rivers, where they are deposited in the riverbeds or even on the beach. In the same way, diamonds that have been detached from a kimberlite by erosion and fallen into the riverbed can be carried to the beach by the current of the water. But what about diamonds found in rivers? Well, that's where you're going to need those sieves I mentioned earlier. You're going to find a clean spot with no rocks around. Then you're going to dig up the earth a bit to remove the gravel from the alluvial deposits. And you're going to start sifting the material. Start with the largest sieve and work your way down to the smallest. always keeping the smallest sieve under the largest so that the material that passes through the mesh of the largest sieve is caught in the smallest sieves. If you can get 5 or 6 degrees of screen, that would be even better. But let's assume for the moment that you're in an actual river with flowing water. Diamonds found in underground mines have a hexagonal shape with 6 sides like this. However, diamonds found in alluvial deposits, whether in dry rivers or flowing rivers, are rounder than diamonds taken directly from kimberlites. Diamonds found in rivers look like a semi-polished stone. Despite being the hardest mineral on Earth, they also suffer from the effects of thousands of years of wear and tear from friction with the other stones in the river. But then you may ask yourself, how can I tell a diamond from other common stones? It's easier than it sounds. There is one characteristic that only diamonds have, and that is their metallic luster. Take a look at the difference in luster between a rough diamond and other common stones. Can you see how metallic a diamond's luster is? I'm sure that if you find a diamond after watching this video, you will have no doubts. Of course, you'll need to do further tests to certify the diamond, but learning to look closely at the metallic luster of diamonds is more than enough. It may be hard to notice at first, but over time, by watching the videos here on the channel, you'll become familiar with the metallic luster of diamonds. If you look at a diamond from a distance, it will look like a piece of polished iron, not a stone. So if you notice something glittering in the gravel of the alluvial deposits, it's a good idea to start sifting. If you're lucky enough to find a diamond, it's likely to be quite small, so try finer sieves if possible. Another important factor now is the minerals that are indicators that there are diamonds in the river that I mentioned at the beginning of the video, because not every river is going to have diamonds. But how do you know if the river you're looking for has diamonds in it? In rivers that have diamonds, you'll find some minerals that are indicators of diamonds, which are mainly garnet, chromite, and ilmenite. In previous videos, I've talked about all the indicator minerals, but these 3 minerals are enough. Garnet, for example, is a gemstone that is much more common and cheaper than diamonds and is sometimes confused with rubies. However, there are some differences. The most common type found in rivers is parope garnet, which has a reddish, dark color, sometimes grayish. And you usually find them like this in rivers, in rounded cubic shapes, with several sides, sometimes semi-polished. Like rubies and diamonds, they are quite heavy compared to ordinary stones of the same size, some of which, when clear, are beautifully cut and can be worth a lot of money. But what is important here is that you recognize and find these stones, because garnets are formed in volcanic rocks under conditions similar to those of diamonds. They can indicate that diamonds are present in the area, just like ilmenite. This is basically an oxide of iron and titanium. This mineral is black with a metallic luster. Its shape is trigonal and it can have some facets. It looks like a piece of raw iron, is very heavy, has a hardness of about 6 on the Mohs scale, and is a strong indication that diamonds may be present. Some emenites can even be mistaken for black diamonds at first glance. The third important indicator is chromite. This is also a type of iron oxide that contains iron and chromium and other combinations of minerals. It has a darker metallic appearance, but is more irregularly shaped, more rustic than ilmenite. They are also very heavy, much heavier than other stones of the same size. It will feel like a small piece of lead in the palm of your hand.
Are dunite, which is this one, and chromite, which is this one. Now they're very similar in colour. The dunite is exceptionally fresh here, and so is a greeny black kind of colour, whereas the chromite is more of a black.
Finding chromite in rivers is also a strong indication of the presence of diamonds, as well as sapphires and rubies. That's it. You found these minerals, but how do you get the diamonds out of the river? In a practical way? Well, you put some river gravel in the sieve and then you make circular movements, turning the sieve, because diamonds are heavy, more so than other stones, and they'll end up at the bottom of the gravel, along with garnets and ilmenites and chromites, if there are any, including gold, if there's any in the river. With circular movements, the heavier minerals will concentrate in the middle, and then you just have to do this process from the coarsest screen to the finest, just as I told you at the beginning of the video. At the end, just spread out the gravel from the sieve and look carefully, because now you're going to have to see the diamond with your eyes. But how do you do it? Diamonds don't have the same luster as ordinary quartz crystals, So don't be fooled by transparent stones. Look for the metallic sheen I showed you earlier. It will certainly catch your eye from a distance. Diamonds are very small, so keep your eyes open to make sure you don't miss them. Don't be fooled by big stones. And when I say big, I mean over a gram, which is pretty big for a diamond. One more important point, when you find your first diamond, remember that it can't always be a quality stone. There are darker colored diamonds that have a lower value and others full of inclusions that will only serve as industrial diamonds. But even if you find a low-quality diamond, it's already a reason to rejoice because you're on the right track. The place has real diamonds, and it's worth looking for more. Even if diamonds are not easy to find, it doesn't hurt to try. You never know when your lucky day will come, do you? But before you rush out to start searching for rocks that could be worth a fortune, there's one last thing you need to know. A lot of people out there do find stones with serious value, but because they don't know how to properly identify the mineral type, they either ignore it or worse, sell it for a fraction of what it's really worth. Unfortunately, this happens all the time. Valuable minerals and even gemstones being sold for ridiculous prices, simply because the person holding them didn't recognize what they had. That's exactly why I created the book, Gemology Journey for Beginners. A complete, straightforward, and practical guide made for anyone who wants to learn how to identify the most common types of gems and minerals, even without professional tools. Inside, you'll learn how to perform simple tests for hardness, density, texture, and luster using everyday tools. With this knowledge, you won't need to rely on anyone else's opinion to know what you found. You'll be able to analyze your discoveries with confidence and maybe even turn this skill into a side income or long-term investment. And if your goal isn't to sell, no problem. The book also includes an exclusive collector's chart listing some of the world's most valuable minerals, their characteristics, rarity levels, and practical tips to organize your finds as your collection grows. Now, if you're still taking your first steps or just not ready to grab the book yet, that's perfectly fine. You can subscribe for free right here on the channel and keep following our videos to keep learning how to identify rocks with critical metals, which are now the new gold of the tech industry. But how can you test your diamond without investing in expensive equipment? On screen right now, you're watching two stones take the same flame and the same dunk in cold water. The one on the left fills with internal fractures and turns cloudy. The one on the right stays intact. That's how controlled heat can separate a cheap fake from a real diamond. Glassy simulants often fail under rapid heat and quench. Diamonds' high thermal conductivity and rigid lattice shed heat fast and hold up far better. In seconds, the truth shows up. Why should you care if you've never bought a diamond? Because the same logic that exposes a fake in jewelry can keep you from throwing away a rough diamond you found outdoors, a dull pebble that could be worth more than a car, sometimes more than a house. While millions buy lottery tickets, the overlooked truth is this: in the right geologic settings, your odds of stumbling upon a valuable gem and recognizing it can be higher than hitting the jackpot. Most people fail for one reason: no method. Today you'll learn the simplest, most accessible test to avoid getting fooled, and we'll apply the same reasoning to rubies and sapphires. And yes, there are 2 bonus tests that confirm authenticity for almost any stone you find in nature. Which ones? Hold that thought. For now, focus on what you see. Watch the key cues: luster, internal integrity, and reaction to thermal shock. Fakes often show trapped gas bubbles, spiderweb cracks after heat, and a milky haze after quenching. A real diamond keeps a bright glass to adamantine luster, crisp edges, and no amorphous fog. With a simple loupe, these signs save you serious money. But where would I even find rough diamonds? That's the other half of the promise. In the next parts, you'll learn which host rocks matter, why certain gravels concentrate heavy minerals, and which field indicators say, stop and look. Stay sharp to the end because we'll reveal something most people have never seen laid out step by step. Fire may look simple, but it's one of the most revealing tests when you know what to watch for. Each material reacts differently to direct heat, and it's in that difference that the key lies. Glass and common simulants have high thermal expansion and low thermal conductivity. This means that when they're heated and then suddenly cooled, the surface and the interior expand at different rates. The result is visible: internal fractures, loss of transparency, and even shattering. Diamond, however, behaves differently. Because of its extremely high thermal conductivity, it spreads heat rapidly throughout its structure. This ability makes it much more resistant to thermal shock. In practice, a real diamond won't break apart or lose its brilliance when exposed to the flame of a lighter or a small torch under controlled conditions. And the best part? This is a completely at-home test. It doesn't require sophisticated equipment. All you need is a strong lighter or a portable torch, a container of cold water, a metal tweezer to hold the sample, a fire-safe surface for support, and of course, protective glasses for safety. Within just a few seconds, the difference becomes clear. Take a look at some practical examples. A piece of glass, when put through this test, shows microfractures that quickly turn into shattering. Cubic zirconia, one of the most common diamond imitations, doesn't break but loses clarity and turns cloudy after cooling. Quartz, another mineral that often confuses beginners, develops cracks along its edges when subjected to thermal shock. And that's the contrast that matters. While common materials deform or lose transparency, diamond remains stable, preserving both its brilliance and integrity. So if the stone in your hand passes this test without showing cracks or visible changes, don't throw it away. This might be the very first sign that you found something truly valuable. But before jumping to conclusions, now that you've seen how glass, cubic zirconia, and quartz react so poorly to heat, it's time to focus on the real protagonist, the diamond itself. This is the moment when the difference becomes clear even to untrained eyes. Unlike simulants, diamond does not deform, develop internal fractures, or lose its brilliance when exposed to a direct flame for a few seconds. Its resistance comes from an extremely rigid crystal structure and its exceptionally high thermal conductivity. That means heat applied to one spot is quickly dispersed throughout the stone, preventing localized stress that could cause cracks. That's why, in a quick test with a lighter or a small torch, diamond stays unaltered. While imitations show obvious signs of thermal stress, diamond keeps its appearance as if nothing happened. The adamantine luster remains strong, edges stay sharp, and under a 10 times loop, you won't find that internal fog typical of amorphous materials or inclusions broken apart by heat. But it's important to understand the physical limits of this test. Diamond is crystallized carbon. Under extreme conditions, it can change. At temperatures between about 700 and 800 degrees Celsius, in an oxygen-rich environment, diamond begins to undergo surface oxidation. At that stage, the surface may show slight dullness or loss of polish. But notice, this is far beyond what a common lighter or portable torch can reach in a few seconds. In other words, in the context of a home test, diamond will not be damaged. That detail is critical. The fire test works as an initial and safe filter. If the stone stays intact, you have strong evidence that it's not a cheap imitation. Of course, as we've seen, some natural gemstones with high hardness, such as rubies and sapphires, also resist heat. That's why fire alone is not a verdict, but it is the first major step in separating what deserves attention from what can be discarded. And this is where the question of value comes in. Picture a plain-looking pebble pulled from river gravel that survives the fire test untouched. For most people, it might slip by as just another ordinary stone. But for someone who knows what to look for, this is a sign that commands respect. Depending on its size and clarity, a rough diamond like that could be worth as much as a luxury car, and in rare cases, even a house. We're not talking about something far-fetched or impossible. We're talking about real chances, far greater than winning the lottery, especially in the right geologic settings. So if you find a material that withstands fire, never discard it without further analysis. Use a loupe, examine the luster, check for any signs of internal fractures or cloudiness. Every detail matters, and every detail could mean the difference between tossing aside a worthless rock and holding a stone worth tens of thousands of dollars. This is also where many people make their biggest mistake. They stop after the first test, and by not knowing the next steps, they get fooled. Or worse, they miss out on the find of a lifetime. That's why next we'll talk about the limitations of the fire test and how to use it properly as part of a complete identification sequence. Up to this point, you've seen how fire can quickly separate cheap fakes from something that deserves a closer look. But it's important to be clear, fire is not a final verdict. It's only an initial filter, useful for eliminating obvious mistakes and highlighting what truly resists. The trap is that some authentic gemstones can also survive this kind of test without damage. Take rubies and sapphires, for example. Both belong to the corundum family, with a hardness of 9 on the Mohs scale and a very stable crystal structure. That means they can handle the heat of a lighter or small torch just as well as diamond. If you heat a blue sapphire or a red ruby, you're unlikely to see fractures or dulling in a quick test. Under a loupe, they'll still look intact, leading to a dangerous mistake, assuming that just because it passed the fire test, it must be diamond. Another case is moissanite, a natural silicon carbide that's extremely rare in nature, but widely produced in labs and sold as a diamond substitute. Moissanite also has high thermal conductivity and can withstand heat without issue. On top of that, it shows a strong brilliance, sometimes even stronger than diamond. To the untrained eye, it can be almost impossible to tell them apart. There are others too, less well known to the general public, like spinel and certain varieties of topaz. Small samples of these stones can handle heat reasonably well as well. They don't have the same hardness or value as diamond, but if your analysis stops at fire alone, they can fool you. And this is the key point. Fire is the first filter, but it's not the final confirmation. Fire says, this one is worth checking, or this one can be discarded. It should never be treated as a full diagnosis. This is where many people go wrong. They stop after fire, convince themselves they found a diamond, and end up tricked by opportunistic buyers. Or worse, they throw away a valuable stone simply because they didn't know there were other tests available. The good news is those other tests exist. They're simple, and you can do them at home without expensive lab equipment. We'll get to them in just a moment. But before that, it's crucial to understand how to use fire responsibly and safely. The first rule is never test a mounted piece of jewelry. When a diamond or other gemstone is set in a ring, pendant, or earring, there's always metal, solder, and sometimes glue involved. Heat can damage the metal, loosen the stone, burn solder, and even release toxic fumes if adhesives are hidden underneath. The risk of destroying the jewelry is real. That's why the fire test should only be done on loose stones. Another essential rule, always wear protective glasses. Thermal shock in fragile materials like glass or quartz can make them shatter suddenly, sending sharp fragments flying. Simple eye protection removes that danger completely. Always use a sturdy metal tweezer to hold the sample, keeping your hands well away from the flame. Never hold the stone directly. Beyond the risk of burns, concentrated heat can travel to your fingers in seconds. Place the stone on a fire-safe base, like a ceramic brick, so the heat doesn't spread to flammable surfaces. And don't forget ventilation. Some synthetic materials or treated stones may release vapors or odors when heated. Testing in open air or in a well-ventilated space protects your health and avoids breathing in harmful substances. These simple precautions make all the difference. After all, it's no use saving a stone if you end up hurting yourself in the process. So the real challenge is this. How do you avoid confusing diamond with other stones that also pass the fire test? The answer is to never rely on a single test. Fire is only the first triage. It eliminates fragile fakes like glass and quartz, and it tells you which stones deserve closer study. The real identification starts when you apply a sequence of tests, and this is where beginners should feel encouraged. You don't need a lab, you don't need an advanced microscope, you don't need expensive machines. The next two tests you'll see are just as accessible, and together they drastically increase your chances of being certain about what's in your hand. One of them is the hardness test, which shows clearly whether the stone can scratch glass and other minerals. The other is the density test, which measures if the specific gravity matches that of a real diamond. When you combine all three, fire, hardness, and density, you create a strong at-home protocol to separate mistakes from real opportunities. And that's the game changer. While millions still believe that diamond identification is something reserved for gemologists with labs and advanced equipment, you'll see that with the right home procedures, you can avoid the most common errors and drastically reduce the risk of tossing away a million-dollar stone like ordinary gravel. After fire, the next step to confirm whether a stone deserves attention is to test its hardness. This is perhaps the most classic method in mineralogy, used for centuries, and it can be applied at home without sophisticated tools. The principle is simple. Harder materials scratch softer ones, but not the other way around. Diamond sits at the very top of the Mohs scale with hardness 10, the maximum value. That means it can scratch almost any other material, including glass, quartz, and even corundum, without being scratched in return. The practical way to apply this is to take the suspected stone and carefully try to scratch a glass surface, like that of a drinking glass, a window pane, or even a lab plate. If it's diamond, the mark left will be sharp, continuous, and permanent. It won't be a superficial line that wipes away with your finger. It will look like a cut, as if made by a fine blade across the glass. The important detail is that after scratching, the stone itself should show no wear. If the sample crumbles, leaves a white powder on the glass, or shows damage, that means it's probably quartz, topaz, or another softer mineral. A simple control test is to try the opposite. Rub the glass against the stone. Glass should never, under any circumstance, leave a scratch on diamond. If it does, then you already know the sample isn't what it seemed. This test is especially useful because it rules out a huge number of common fakes. Glass, calcite, feldspar, and even some lab-grown imitations won't withstand it. Of course, there is one notable exception, moissanite. With a hardness of about 9.25, it can also scratch glass easily. That's why hardness testing alone is not enough. It serves as an additional confirmation, showing that the stone is in the expected range of resistance for something that could be diamond. But to separate it for certain, you need to complement it with another physical property, density. The density test, also called specific gravity, is one of the most reliable you can do at home with simple instruments. The idea is to measure how much the stone weighs compared to the volume it occupies. Every mineral has a characteristic density range, and this allows you to spot differences invisible to the eye. The most accessible method is water displacement. You'll need a digital scale and a small graduated container, like a plastic measuring cylinder or even a kitchen cup with milliliter markings. First, weigh the dry stone and note its weight in grams. Then fill the container with water to a marked level and carefully place the stone inside, watching how much the level rises. That rise corresponds to the volume displaced, in milliliters equal to cubic centimeters. Now divide the weight by the volume, and you'll have the density in grams per cubic centimeter. If the result falls between 3.5 and 3.53, you have strong evidence it could be diamond. If it's closer to 2.65, it's quartz, which is much lighter. If it's above 5.5, it's likely cubic zirconia, easy to mistake by looks but revealed by its excessive weight. Sapphires and rubies, which are corundum, fall between 3.95 and 4.1, just a bit heavier than diamond, which makes the distinction possible in practice. There's also a second way to measure density, even simpler and more precise, known as hydrostatic weighing. For this, you only need the scale and a cup of water. First, weigh the stone normally in air, then suspend it from a thin thread or place it in a light mesh and submerge it in the water without touching the bottom or sides, and weigh it again. The difference between the weight in air and the weight submerged corresponds to the buoyant force of the water, which equals the stone's volume. From there, divide the weight by the volume to get the density. This method removes visual reading errors and works with stones of any shape. What's interesting is how these numbers reveal more than appearances. Sometimes a clear, shiny stone that looks precious is nothing but glass. Other times, a dull and ordinary-looking pebble can reveal itself, through its specific gravity, to be something much rarer. This is where technical knowledge outweighs intuition. Think of a practical example. You pick up a rough pebble from river gravel. It survives the fire test, At that point, it could be diamond, but also sapphire or moissanite. Then you scratch a piece of glass and the line is clear. Again, it could be diamond, but also moissanite. Finally, you do the density test and get a value around 3.52. Now the margin of error drops drastically because moissanite would read differently and sapphire would be over 3.9. The combination of these three steps is what brings confidence and reduces the risk of being fooled. This at-home protocol is powerful because it's based on immutable physical properties. A diamond will always have hardness 10 and a density close to 3.52. It doesn't matter if it's cut or rough, clean or covered in clay. These traits don't change. Fakes may mimic brilliance, color, and even cut, but when it comes to physical proof, they fail. Many people don't realize that major diamond discoveries often began this way, with someone curious testing a stone that looked worthless and noticing it behaved differently. In the 19th century, during the first diamond rushes in South Africa, entire families sifted through gravel and manually tested hardness and density. That's how plain-looking stones turned out to be diamonds weighing dozens of carats. The same story still plays out today in small-scale mining areas. It's important, however, to stress that each test must be done carefully. When scratching glass, don't use excessive force that could break both the glass and the stone, sending shards flying. The scratch should be firm but controlled. In the density test, avoid air bubbles clinging to the stone's surface, as they can alter results. Always dry the stone before weighing, and repeat the process 2 or 3 times to ensure consistency. Once you master this sequence, fire, hardness, and density, you create a strong barrier against mistakes and greatly increase your chances of not overlooking something truly valuable. It doesn't matter if you found the stone on a dirt road, in a riverbed, or inherited it without knowing what it was. These tests are within your reach and are enough to separate with high confidence what's worthless from what could change your life. And the most striking part is that all this knowledge can be applied without spending almost anything. With a lighter, a piece of glass, a simple scale, and a cup of water, you're already equipped to avoid being deceived. While many still believe diamond identification is impossible without being an expert, you now know there are practical, accessible ways to get very close to the truth. Finding diamonds in nature isn't about pure luck. It's about being in the right place and recognizing the signs most people overlook. The first step is to understand the geological setting where it actually makes sense to search. Diamonds form deep in the earth and reach the surface through rocks called kimberlite and lamproite, ancient volcanic pipes that acted as conduits. Over time, weathering alters these rocks. The fresh, bluish material is known as blue ground. As it oxidizes, it takes on a yellowish aspect, the yellow ground, where collecting is often easier. These formations are mostly found in stable cratons, very old portions of the Earth's crust. In the United States, for example, the Wyoming Craton and parts of Colorado have produced historic finds. But a diamond prospector needs to go beyond maps. There are field indicators that shout stop and look. Among them are heavy minerals that typically occur with diamonds in kimberlites and secondary deposits. Chromium-rich garnets, chromite, ilmenite, chromium diopside, and pyrope. The combined presence of these minerals in gravels or soils is a valuable alert that the area may be connected to diamond-bearing pipes. If you pan or wash sediment and see bright red garnets mixed with dark grains of ilmenite, an attentive explorer knows they're not in an ordinary spot. Rough diamonds themselves also have distinctive features that make them recognizable. They may show curved faces, often forming rounded crystals in rhombododecahedron shapes, or edges worn down by river transport. Another key clue is their greasy luster, different from the glassy look of quartz or common glass. When wet, a diamond tends to keep that oily appearance, while other minerals simply look wet. Beyond primary kimberlite sources, rivers act as natural concentrators. Because diamonds are relatively dense, they accumulate in specific spots known as secondary deposits. In old channels, inner bends of meanders, plunge pools at the base of waterfalls, and behind large boulders in riverbeds, water flow slows down and heavy minerals collect. The so-called lag layers, compacted pavements of gravel, are also strategic places. Often, small concentrations remain preserved in cracks of bedrock for thousands of years. To investigate these environments, collecting needs to be practical and systematic. Screening with progressively finer meshes is the first step, eliminating coarse material and retaining the fraction that may contain heavy minerals. A gold pan also works well for separating heavies from lights, leaving behind what's worth examining. In more organized setups, grease tables or oily fabrics are often used, since diamonds are hydrophobic and tend to stick to greasy surfaces while other minerals wash away. With concentrated material in hand, a 10 times loop becomes indispensable. Under magnification, you can check for true adamantine luster, curve fractures, absence of internal bubbles, and resistance to marks. If a sample looks suspicious, just apply the sequence you already know: fire, hardness, and density. This chain of tests eliminates most doubts and helps avoid throwing away a valuable find by mistake. In the United States, there's even the advantage of public digging sites. The most famous example is Crater of Diamond State Park in Arkansas, where anyone can dig, screen, and keep what they find. It's one of the only dig and keep parks in the world, meaning everything you discover is yours. Not surprisingly, many large diamonds have been found there by ordinary visitors. Proof that this isn't a myth, but a real opportunity. In addition, parts of the Wyoming Craton and Colorado are known for old pipes and indicator mineral trains that help guide local prospecting. One aspect that can't be ignored is legality. Every country, state, or county has its own rules. It's essential to respect permits, avoid private land without permission, and understand environmental regulations before collecting. Looking for diamonds without authorization can lead to serious problems, even if the discovery itself is legitimate. Ethics and respect for the law are fundamental parts of the practice. Finally, there's a very common mistake that must be mentioned: confusing milky quartz or clear calcite with diamonds. At first glance, they can look similar, especially when water-worn in gravel. But quartz is lighter, with a density of about 2.65, and it doesn't scratch glass as cleanly. Calcite is even softer and reacts easily to weak acids, like vinegar, by fizzing bubbles. Paying attention to these simple details prevents frustration and greatly increases the chances of recognizing a real diamond. Now imagine that after watching this video, you're walking along a dry riverbed and you come across a small transparent pebble among quartz fragments and dark gravel. At first glance, it doesn't look like much, but you decide to test it. First, it resists fire without showing cracks or cloudiness. Then it scratches glass with ease, leaving a sharp, permanent mark. Finally, you measure its density in a cup of water and get something close to 3.5. Every detail seems to confirm it could be a rough diamond. And this is exactly the moment when the inevitable question arises: what do you do now to avoid losing money? This dilemma is far more common than most people think. Many beginners stop right here, caught between the excitement of discovery and the insecurity of not being absolutely sure. And it's in this gap that opportunists move in. They approach with a rehearsed line: "That's worthless, it's just quartz." And they offer a token amount to take the stone off your hands. What might feel like an insignificant sale to you could actually mean losing something worth as much as a car or even a house. There are real cases of diamonds sold as glass and rubies traded away for pocket change, simply because the finder didn't have the right knowledge. The risk of confusion is real. Milky quartz, clear calcite, and even some natural glass can look like diamonds at first glance. Without a method, it's easy to make mistakes. But here's the important detail: diamond isn't the only valuable stone you might come across. Even when a sample doesn't confirm as diamond, it could be sapphire, ruby, spinel, or even a gem-quality garnet, all of which carry significant market value. The problem is that without information, many people discard what could have been used, or sell for pennies what could have been worth thousands of dollars. That's why practical, organized information is worth more than any guess. To help avoid these mistakes, we created the channel's Field Guide, a straightforward tool designed for real-world use, showing in detail how to apply the tests you've just learned and many more. Inside, you'll find simple checklists so you don't skip steps, density tables to compare your results, real photos of indicator minerals, and examples of rough stones to train your eye. It's like having a pocket manual that turns curiosity into confidence and protects you from traps. With this guide, you won't have to rely solely on the word of someone trying to buy cheap. You gain independence to know what you're holding, to negotiate clearly, and to avoid the tricks that repeat themselves every day. After all, it's not enough to simply find a valuable stone. You need to recognize it and make sure it's valued properly. And this is only the beginning, because even once you can tell a diamond apart from quartz or cubic zirconia, there's an even bigger challenge ahead: avoiding the most common mistakes made at the moment of selling. These mistakes make people lose small fortunes simply because they don't understand market details, evaluation processes, and basic identification techniques. And that's exactly the topic of our next video. We'll reveal the most frequent errors that turn valuable discoveries into financial disappointments, and how you can protect yourself from ever falling into those traps. So the next time you find a suspicious stone that survives fire, scratches glass, and shows the right density, remember this: the real risk isn't being wrong about whether it's a diamond. The real risk is not knowing what to do afterward and letting someone walk away with what could have changed your life. Thanks for liking and subscribing. Good luck, Gem Hunter.